So I've got a Gaugemaster D controller and a Gaugemaster Shuttle unit, and I'm going to power this section of track, radius 1, around the rocket, and another section of track that's raised up around here using the shuttle. Then a forward section of track, this one here, which is second radius, will be manually controlled. So let's see how that goes. Just like Thunderbirds it is. So this is the first radius track that's going around the rocket that I'm going to set up on the shuttle unit. I've got a Gaugemaster D controller. I've also got this Gaugemaster Shuttle unit, Super Shuttle. And it comes with a couple of diodes that must be connected in the same direction on the track. I'll explain more in a little while. So what I've done, I've actually Tipexed on some paint so I know which direction they go for sure. The actual controls, the way they're wired up, are like this. So you essentially have a 16 volt supply going into the shuttle unit, and it needs that power all the time so it knows what it's doing. You also have a controlled supply which is set by the variable rheostat on the Gaugemaster D controller, so whatever power rating that's set to, that controls the locomotive. If I turn that off or very low, it's still got a 16 volt permanent supply fed to it, and then there's a couple of wires going out to the track, and they go to the track quite simply, one each side of the rail, and then one of these rails is broken at two places, and you literally cut through the rail there, you cut through the rail there, and you solder over a diode connection, that diode that's supplied in the pack, you solder that over the joint. The diodes must face the same way. If they don't, then the train isn't going to stop, it's going to carry on and drive off the end. Now, you can use insulated fish plates. They're plastic fish plates instead of metal fish plates, just to help guide the rails, keep them straight. Well, you don't have to use anything at all, but you must have a break in the rail that is bridged by that diode. That's most important, and that is a bit of electronics needed to be soldered onto the rail so that the shuttle unit will function correctly. So let's give it a go. So this is the way it's connected up. 16 volt AC constant supply goes into this part of the Gaugemaster Shuttle. The middle wire goes to track 1 or 2, that's the controlled output. And then this final wire goes to the track itself. It goes in the middle between the two diodes. And what I've also done is linked another piece of wire going to another track so that can get powered at the same time. Well, I can get one lane shuttle in, I can't get two though. And what happens is this lane is controlled, and I thought the power would stop on that lane too. It doesn't. This one stops and that one carries on. So I'm just going to have one lane operational as the shuttle. Still, it all functions, I just need to put it in now. So here's the final track configuration. Shuttle unit on the radius 1 curve and normal drive on the radius 2 curve. So I'm controlling that one manually, and then the shuttle unit controls the other one as and when it wants to.